This is an introduction and overview of the Dynautics simulators, what they aim to do, why you would use them, and how you set them up to simulate your vessel. My name is Alison Little. I'm a project engineer at Dynautics. We're based on the south coast of the UK near Portsmouth, and we've been developing simulators and autopilot control systems for uncrewed vessels since 1996. When you're considering your mission requirements and the type of vessel you require, here's some of the other things you look at. While some of them are bought off the shelf, machinery, sensors, you're unlikely to be developing thrusters, servos, comm systems from scratch. However, if you're developing a new body, control system or onshore control station software, then these things require a lot of testing. If you're developing new control algorithms, then you'll definitely want to use simulation to help your development. Why use simulation? To make testing more efficient. Sea trials are expensive, time-consuming and risky. Simulation provides a platform to test and evaluate the performance of vessels, equipment and systems in a virtual environment. Simulation minimises the risk of losing or damaging a vessel in trials. It produces a safe and controlled environment to test vessel performance and identify any potential risks. Simulation allows for the exploration of different operating scenarios. This is important because it enables us to understand how our vessels perform in different conditions and environments, providing valuable insights that can help us improve efficiency and safety. Simulation tests both the onboard control system and the onshore monitoring and control console. This is essential in ensuring both systems are synchronized and are functioning correctly, providing a reliable and efficient vessel performance. Simulation can be used for training operating personnel. It provides a realistic training environment that allows operators to practice and develop their skills in a safe and controlled environment. When you finally commence sea or lake trials, you can be sure you are doing so with all the teething problems addressed, so you can get the best benefit from the trials. Another reason we use simulation is to certify that the control system meets industrial standards. For instance, the IEC 62065 standard for testing track control systems. What does a simulator do? Basically, the simulator simulates the wet stuff. The stuff that's expensive, time-consuming and risky to carry out at sea, and you want to get right when you do go to sea. The response of the machinery to the demands, e.g. you command 15% of maximum RPM on the main engine and it takes time to respond. Maybe there's a detent and it won't run at less than 20%. These things you want to simulate. The response of the vessel to the machinery demands and to the operating environment, tides, waves, etc. The response of the sensors to the vessel's movement and display of the resulting movement of the boat. This might be simple in terms of dials, readouts, or wireframe model of the vessel, or could be more complicated and show a 3D rendered view. A little bit more about the vessel response model. We don't think that you need a full CFD simulation of the detailed flow of the water and the wind around the vessel. You need a representative physics-based model which reacts to the demands from the control system in the way that you would expect. There are standard models of ship movement which are used for certification of autopilots. But more complex models may be required to model your vessel. Not just the vessel characteristics, also the machinery fit and specific machinery response, which can be adjusted to match the real system. How to interface with the real world. Firstly, it's good to test the simulator using demands from within the simulator, so we provide user customizable sliders. As well as testing that the vehicle behaves as expected, you can use this mode to control the vessel directly and check the output from the sensors. Interfacing with the control system, different methods may be required, for instance serial, analog, PWM or digital signals. The Dynautics simulator provides a range of interface options and we're continually adding new ones. You can send demands using a simple serial format which we've defined, or we can intercept the commands to the machinery, or we can measure the behaviour of the real machinery, obviously more practical for hydroplanes and rudders, etc. than engines. In terms of the output of the sensor data, It's best to mimic the real sensors as far as possible, so we support NEMA 0183 and NEMA 2K, etc. over serial and Ethernet, as well as analog and digital outputs. To explain how we use the simulator to simulate a range of vessels, I'm going to go into a little more detail about ShipSim. The Dynautics ship simulator includes a composite model which allows you to equip your vessel with a range of engines, rudders and thrusters. We define these and link them to the sliders, to the input from the autopilot and to the simulation engine via a lookup table of machinery sockets. We configure the response of the vessel by breaking down the effects into component parts. The hull itself with moment of inertia and added mass, the hydrodynamics, the response to waves, and the aerodynamics. And we configure the sensors fitted to the vessel and the way in which they output their readings. So, coming to the end of the introduction to our simulators, I've talked about when you would use simulation and the features provided by our simulators. Please watch our videos which demonstrate using our ShipSim and AUVSim simulators to model a variety of vessel types. And if you would like more information, please contact us through our website.